Hey there and welcome back. So today we're going to talk about sprites. Now we can't talk about sprites in this sense without also talking about input, because now we're going to see how we can make a joystick control of sprites. Now we have seen that before, but now we need to take a look at how we can put that into our system here. So basically what's going to happen are two things. We need to read the joystick input and we need to move the sprites or handle the sprites. So I'm going to use two libraries for this. The input library and something I'm going to call the Sprite Library. Now, I mentioned this before, but I have been a little back and forth on what terms to use for our little guys moving around on the screen, stuff like that. Should I call them sprites or objects? Now, on the NES, Nintendo Entertainment System, it's a good idea to separate those two terms, because a sprite on the NES, that's an 8x8 tile of pixels, and Mario's sprite when he's small in Super Mario Bros. 1, that's 4 sprite tiles like that. But when he's moving around, we can think of him as an object because he has collision and there's a lot of stuff going on with the little Mario character. So in that sense, he's an object made up of several sprites. Now, for our Commodore 64, it's a little different, because Commodore 64 sprites, first of all, like we've seen, they are bigger than sprites on the NES. They are actually so big that it's not a problem to use just one sprite to make a character, like we see here. But also, the Commodore 64 sprites have built-in collision. So there's sprite collision and background collision built in to every sprite. Now, it's not a great collision routine, so unfortunately we're going to have to make our own. But my point with all this is that I'm just going to call this a sprite. So at the end of the day, what my point with all of this was that I'm going to call this a sprite library instead of an object library. So the sprite is both the graphics and the whole thing moving around, all of that stuff. Alright, hopefully that makes sense. The point is, we need to read input and we need to move this little guy on the screen. So let's take a look at that now. But before we do that, let me just say a few words here now. So going forward now, things are going to get more complex. It's going to be more code, more things to keep track of and stuff like that. And I can't explain every little thing in detail going forward from now, because it's going to take way too much time. And when we get to line number 750, then I would have forgotten, and probably you would have forgotten, what I said just a few minutes ago about a line further up. So I don't think that's the best way to do it. Now, since you're going to get this code at the end of the course, and you can study it on your own, and hopefully this will be okay. But let's also remember another thing. This code is specifically made for this course. So it's not going to be the perfect code. It's not going to be the optimal code. You should have done thing this way. You should have done something that way. Yes, I understand all of that. But this code is made for this course specifically. Which means that I have everything I've done here, I've made it so that it's as easy as possible to read and understand. So that's how I've made this code. So I think it's important to remember that as we move forward now. So things are going to get a little bit more complex, but the code is written to be as easy as to understand as possible. So it's not going to be perfect, but hopefully it's going to be fairly easy to understand. Alright, I just wanted to mention that. Now there's also I've also put in a lot of stuff here in our project that has to do with inputs and sprites. Several I've included a few constants now, constant files. So for example, sprite constants. I've made this one for sprite X, sprite Y, for example, and why I don't have sprite X and Y for the rest of the sprites. I'm gonna take a look at that in just a second. But yeah, I have several, like we've seen before, I have several memory addresses that has to do with sprites. And just notice what I did here at the bottom. Sprite pointer. I've set screen RAM plus 300 F8. Now that's because if you move screen RAM, then the sprite pointers will follow. So they will always be 300 F8 behind the actual screen RAM here. So just something to keep in mind. And sprite pointer index, like I said, let's just remember that it's easiest to remember that you have sprite's address, the address where the sprite graphics are crammed in, divide that by 64. And just remember that 64, that's 64 bytes, that's one sprite graphic. So if we can remember those two, then we should be okay. Alright, but anyway, that's the sprite constants. I've also included input constants. Now this is just the memory address for joystick 1, joystick in port 2 and joystick in port 1, and the idle state for joystick in port 2 and the idle state for joystick in port 1. So as you can see, those two are almost the same, except joystick in port 2 has a 0 in the front there. Now I've also made some directions for the joystick. So joystick up, that's the bit here, and joystick down is a bit here, and that's actually how we are reading the joystick input. We're gonna come back to that. And down here I just have a few for reading the keyboard. So yeah, and I've also made one just for directions. So directions for sprites. Here we have up, down, left, right, but also I made a few for facing directions. Alright, so the point is that I've included a few constant files here now. But I've also included a file here called sprite tables. Now, we can't look at everything at once. And I don't know if you can see here on the right, but it's a pretty big file. So we can't look at everything at once, but there are a lot of tables in here that has to do with sprites, and every one of these has 1, 2, 3, 4, 5, 6, 7, 8 entries. So for every table here, there's an entry for every sprite. Since I can have 8 sprites, there's an entry for every sprite, which means that this table keeps track of the X position for sprite 0, sprite 1, sprite 2, sprite 3, so on. This keeps track of the Y position for all sprites. This has the vertical speed for all sprites, and so on. So there's a table for a lot of things, and every table has 8 entries because there are 8 sprites. Alright, so I've crammed a lot of things in here now, as you can see. And also, most importantly now, we have my input library and I have my sprite library. So let's just quickly take a look at how my game works right now before we do anything else now. There we go. So okay, here we go. So now I've built on what we did last time. Here is my room 0. Now here is my sprite in my room 0. Now as we're gonna see going forward now, things aren't really isolated anymore. We have a room, we have a sprite, and we have our input, and things are starting to connect. So both my like I said in the beginning, my input library and my sprite library are going to work together now, because now I'm moving my sprite around. So I can move it up, down, left, right, and also diagonal. And like we remember from earlier, when he gets to the edge, he wraps around. So now I have now I have the basics for a game, right? I can draw the background, I can read input from the joystick, and I can display a sprite. So now I have a pretty basic setup right now. But how is this? Let's take a look at how I made this work. Alright, so first of all, let's go to my game code here. So last time we looked at the room library. That wasn't too complicated. That was actually pretty simple. And we ended up with a routine to load a room. So I just made a few comments here to separate things. So here I say load room 0. Now, if you go down here, it says initialize sprite 0, which is, we can have written initialize player instead. So what do I write in here? Now I write load X with 0. So that's gonna mean sprite 0. Then I say load A with 100 and store that in these two tables, sprite X pos, sprite Y pos, both of them comma X, which means sprite 0. So these are two tables in my sprite tables file. And like I said, both of those have 8 entries. Since we say load X with 0 now, both we are storing 100 at the first entry in both of these tables. So let's see here. So now we're storing 100 here. Oops, 100 at the top one, and we're storing 100 at this one, X and Y position. Now that's just a table. So this, as you can see, this isn't the memory address that updates the sprite position. These are just tables. But I'm storing X position and Y position in those tables. Then I have something else here that says load A with 10. Store that in sprite vertical speed and horizontal speed. Again, those are tables. So I have tables for that. As you can see here, here's the horizontal speed. And like I said, it's an entry for every sprite. Alright, so basically what I'm saying here is set the vertical and horizontal speed to speed 10. Now exactly what that means is just something that we need to figure out, and maybe trial and error, stuff like that. But let's just accept right now that it's vertical and horizontal speed 10. Then I'll just do what we've seen before. I load A with a 1 here, store that in memory address D01C, which is this one, to enable multicolor for sprite 0. And we have also seen this before. We are storing the colors for extra color 1 and extra color 2, because I'm going to use multicolor like we just saw. So I'm storing black extra color 1, white extra color 2. And then here, this is the actual sprite color. So remember, even though it's a multicolor sprite, every sprite just has one unique color. So I'm loading light red, storing that into sprite color, comma X. Then that's new. And what this is, so this is memory address D1027 sprite color. But when I say comma X behind there, it means that this X thing will be an offset. So the way it works with sprite colors, that you have one after the other in memory. So you have D1027, that's the color for sprite 0. D1028, that's the sprite color for sprite 1. D1000, so on. So there's one after the other in memory. 8 memory addresses that keeps track of sprite color. So one memory address for each sprite. And since they are stored after one another like that, then we can just use this technique that we do with tables. So comma X. So if I said load X with 2 up here, then everything that I did here would be concerning sprite number 2. X position, vertical speed, color, whatever. So just by using this method of using the X register as an offset, we could control what sprite we were working with. But hopefully you can see here that I didn't have to write comma X, since this is sprite 0 now, because it's the first address anyway. But I'm just trying to show you how we can use X as an offset, because that's going to be important in our sprite library. Here we have this thing with a sprite pointer index. So that was 80 when we have sprites at memory address 2000. So I'm storing that in the sprite pointer, which in this case is 07F8. So screen RAM plus 3F8. That's the address for sprite pointer. But like with the sprite color, there's also one address for every sprite pointer. So 8 memory addresses for the 8 sprites. So again, I'm using this X method as an offset. So since X is 0 now, I'm loading this sprite pointer for sprite 0. So hopefully that makes sense. Then here we have another memory address, D015 sprite enable, and by loading 1 into here, storing that here, I'm enabling sprite 0. So hopefully most of this isn't really new, but now I've set it up like sort of a system here. So now I've set all these values for sprite 0. Now remember what I said in the beginning. What we do now, there's no really right or wrong, but the important part is that you have to make something that makes sense to you. You have to give things meaning. Now, there's no, the sprite X position here. That's just something that I came up with for a name for this table. So the point is, you need to make systems that make sense to you, and because we're starting with LDA, STA, very basic stuff, so we have to build systems ourselves. And like I said in the beginning, we need to give meaning to everything. What does it mean that I have a table here that says sprite v speed? Well, I'm gonna do some program a system, so that's going to mean sprite vertical speed. Hopefully that makes sense. So here I've set up a lot of stuff, and all of this is concerning Sprite 0, which is my player. So now I've set up all of that. But let's get back to this one. I was just storing 100 in these two tables, Sprite X position, Sprite Y position. But I'm not updating those memory positions. Where is that happening? Well, if we go down to game loop, I have read joystick port 2 and I have sprite handler. Now here's a little spoiler for you. This updating of X and Y position is not happening in any of these two. We are not updating memory position, X and Y position in memory for sprites. We are not doing that in any of these two. So where is it happening? Well, if you guessed in raster interrupts, you're right. So if I take a look at my raster interrupt routine now, you have seen this before, IRQ. I have one subroutine going in here. It's in my Sprite library, and the subroutine is called update sprite X and Y. That's happening 50 times a second on my PAL machine here. Alright, so now it's probably a good idea to look at my Sprite library. Right, here we are. So, here's my Sprite library. Now I have one subroutine here called handler, Sprite handler. But first, let's go to the bottom and look at another subroutine in my Sprite library. Update sprite X and Y. Oops. Alright. So update sprite X and Y. Now this is actually a loop. So I'm starting with loading X with 0. Loading X with 0. Update sprite X and Y loop. So what am I doing here? Well, I'm loading. Here it comes. Sprite X pos, X. So here's the table that I'm temporarily storing X and Y positions in. Now here in the actual updating routine, I'm reading whatever was stored into there. Then I say store that into temp X pos. That's a variable. We're gonna come back to that in just a second. So I do that for the X position and the Y position. Load what's in that table for this specific sprite. Now the first one is going to be for sprite 0, right? Because we start with we're loading X with 0 here. We're storing those into two variables, but then we get down here. Transfer X to A. Whatever is in X now, transfer that to the accumulator. And first of all, I need you to put it on the stack, because I'm gonna need it back in just a little while. But we're transferring whatever is in X into A, pushing it to a stack, and then we say ASL, asymmetric shift left, which means that we're doubling this number. So we are doubling what we loaded into X earlier. Asymmetric shift left, shifting bits to the left, that means we're doubling that number. Now we can't do this with numbers in X. That's why I have to first transfer X to A, and then double that number, and then do the reverse, transfer A back to X. So I'm just transferring it to the accumulator so that I could do this, because I can't do this in the X register. But I also, let's remember, I also pushed the value to the stack before I doubled the number. Alright, let's keep track of this now. So now I get down here, and then the X number is now doubled. So I say now, load A with temp X pos, the variable that I stored the X position in up here. Load A with that. Now store it in sprite x comma x. Sprite x, that's this, the memory address for the x position of the sprite, but it's the memory address for sprite 0. So what about all the rest of these sprites? Well, here's the thing. You see here, the way Commodore made this, they didn't separate sprite x position, so x position for sprite 0, 1, 2, 3, 4, 5, 6, 7, and then sprite y position for sprite 0, 1, 2, 3, 4, 5, 7. No, they alternated for whatever reason. Maybe it made more sense to them that way. So we have sprite 0, x, y position. We have sprite 1, x, y position. We have sprite 2, x and y position. So you have sprite 0 first, x and y, sprite 1, x and y, and so on. So it's not an easy table to read. So in for example sprite color, where you have one address after the other, sprite color for sprite 0, sprite color for sprite 1, sprite color for sprite 2, and so on. That's just like a table, right? This breaks that logic a little bit, since we have the x in position and then the y position, then the next sprite, x position and y position. So it's not a full table of x position for all the sprites, a full table of y positions for all the sprites. They're mixed together like that. But that's why I do what I did here. That's why I doubled the number. So by doing that, I can sort of handle this, because first I have my sprite 0. Now if I bit shift to the left on sprite 0, well, try to double 0, that's not going to work because it's just going to be 0. Alright, fine. So in this first case, it's going to be load tempos, the variable, store it in sprite x comma x, and we doubled the number, but it was 0. So it's just going to be 0. Fine. Same with this one. Alright, then we say pull from the stack. That we did that. We pushed it to the stack up here. Now we're pulling it back. Transfer a to x. Increment x and compare x with 8. Have you reached maximum number of sprites yet? Well, if not, branch if not equal, update sprite x and y loop. So if we haven't reached 8 yet, go up here again. So it's just a loop, a little loop like that, that's going to go 8 times, because we have 8 sprites. And for every sprite, it's going to be updating the actual memory address for x and y position. And here again, I'm just reading those tables, but now since we increased x by 1 here, now this is the x position for sprite 1, the y position for sprite 1, and I'm storing it in those temporary variables. It's important that I do this first, because I need to load x position and y position for sprite 1 now, and x is 1 at this point in time. But then I do the same. I make sure that I have backup of what's actually in x now, so number 1, and then I double it. So it's number 1, but if I bit shift to the left, it becomes 2. So bit shifting 1, the number 1, if we do 1 bit shift there, it becomes number 2, because we're doubling. When you bit shift to the left, you double a number. Alright, we do that. So then we load what we stored up here in our variables. Load that, store it in sprite x position comma x. Now that's 2 now. So sprite x, alright, that's this, d1000. That's what sprite x is. So the memory address for the first sprite. Alright. So I'm storing it in the memory address for this first sprite, comma x. Now x is 2. That means that this is not memory address D000 anymore, because I have this x. This is now memory address D002, because since x is 2 now, we add that to whatever this is. Alright, well, D002, yeah, that's the x position of sprite 1. What about this, temp y, sprite y, comma x? Well, sprite y, that's this D1001. So the y position of sprite 0. Alright, y position of sprite 0, okay. But we have comma x here, and right now x is 2. So we're adding 2 to this address, D1001, which is going to leave us at memory address D1003, which works out great because D1003, that's the y position of sprite 1. So just by doing this little trick, I can get around the system that Commodore made with the alternating x and y. So it's not really clean because you don't have all the x positions for the sprites and all the y positions for the sprites. But by doing this little trick, we can get around it. So pull from the stack, transfer back to x, and increment x, compare with 8. So the first time you see something like this, it might be a little bit confusing, I don't know. But it's a really nice way to just update all of the positions in memory. So that's what's happening in the interrupt routine. Just updating the actual positions in memory for x and y. And I do that for all 8 sprites. Alright, so I set up all these things first, and now we know that the x and y position is actually updated in memory in the raster interrupt routine. But here in my game loop, I have my input library and read joystick 2. Now, we don't actually need to look at this in detail, because this is pretty much exactly what we did in the episode about reading input from joystick. So I have a library here called input, and I have a subroutine called read joystick 2. I start that routine by loading x with 0, because I know that the player is sprite 0. So I'm loading x with 0 here. Then I just do what we did before. Read the memory address for the joystick in port 2. And I'm comparing it to if it's idle. So that was something I specified in my constants file for my input constants. So I'm loading this, comparing it to that. If it's idle, then we go here. But if it's not idle, then we go here. So if it's idle, then I clear the direction of the sprite. So we haven't looked at that either. So let's go to sprite tables. I have a table called sprite direction. That's going to keep track of what direction every sprite has. So every sprite has their own little entry here. 1, 2, 3, 4, 5, 6, 7, 8. So just like all my other sprite tables, this one has 8 entries, one for each sprite. So this is going to keep track of sprite 0. What direction does sprite 0 have? So now if we go back to input library, if my joystick is idle, if I'm not moving the joystick, then I clear the direction, I just clear all directions for sprite 0. And I jump to done reading joystick 2. So that's all I do if the joystick is idle. If it's not idle, then I jump down here, I read the joystick, and comparing it to, are we moving the joystick up? Well, if we're moving the joystick up, then I do this little trick. Now, let me also just mention, at this point, it's a really good idea if you're comfortable with all the basics that we talked about, because now we're getting to a stage where I can't explain all the basics for every line of code. But if you remember, by using OR, I could set bits. So what I'm doing here, if the joystick is pushed up, then in my table here for the X position, which is sprite 0 right now, because we loaded X with 0 up here. So what I'm saying here is load that position in the table and OR with up. Now up is something that I specified. Up is something that I specified in my directions constants file. So this one, it's just something that I specified here. This is going to mean up. So that's what I'm doing here. And I'm ORing it with that and storing it back, which means that now the direction is set to up for sprite 0. And if I also, if I'm not holding up on my joystick, then I clear that bit by using this trick, load whatever that was, and with 1 1 1 1 1 1 1 1 1, so 8 ones minus the up bit. So it's going to be the same as doing that. It's going to be the same as doing this. If we and we use 1 on all of this, but 0, then it's going to be 0 at this last one. So we're clearing that. If we're not holding up on the joystick, we clear that direction. Alright, so same thing for down, same thing for left and right. I just check the joystick direction and I set or clear the bit, because there's a bit for every direction. And just by doing this, so I'm not saying load A with right, for example, and store that in the sprite direction, because that would overwrite what was there before. But using this and or trick, that means that I could have two directions, so we can have up and left at the same time. So that's probably something that you would want in your game, so you could go in diagonal directions. Yeah, so that's what's happening in my input library. So when I'm running this subroutine, I'm reading the joystick input and I'm setting the direction of the sprite based on what direction I have on my joystick. Then we have this one. In my Sprite library, I have this subroutine called handler. So Sprite library, that's here now. So this is also just a big loop. In my Sprite library, I have this handler subroutine. Start by loading X with 0, and then I have a handler loop. Now eventually this sprite handler is going to get really big, and we're not going to view all of that in detail in this course. So that's something that you're going to have to study on your own. But for now, let's look at the beginning here, just moving the sprite. So I start this loop loading x with 0, of course. Then I say check vertical speed timer. So I have in my let's see here. Yeah, so I have for my vertical and horizontal speed, I have two tables. One called Sprite V speed timer, so vertical speed, Sprite vertical speed timer, and one called Sprite vertical speed. This one is the one that I specify as an actual speed. So if you remember what we did here in my game code setup, I loaded a with 10 and stored that into vertical speed. So that's I'm saying I want vertical speed to be 10 for this particular sprite. Alright, but I also have a vertical speed timer. So if I now go back to my Sprite library, so I start this handler routine here by checking vertical speed timer. So I'm loading vertical speed timer and comparing it to vertical speed. Why am I doing that? Well, it's to again give these things meaning. So I want this speed timer thing to be sort of delay, and it's a delay that has that table right here has 8 entries, right? So every sprite can have their own delay. So one sprite can be moving fast, one can be moving slow, whatever. But just by comparing those two and say, are they the same? Well, if they are the same, sprite timer reached. So we go down here. Now vertical speed timer reached. So we go down here. And then we reset the timer by loading a with 0 and storing it in Sprite V timer, that table. But if they are not equal, which they won't be at the beginning, we say, alright, they're not equal, so we go down here, increase vertical speed timer, x. So it just goes up by 1. And then we jump past the rest of this. So if we just by comparing these two, we can make some sort of delay system. All right, so if the vertical speed timer has reached the actual speed, then we go down here, reset this timer, because the same thing is going to be happening the next time around. Yeah, hopefully that makes sense. But check up direction. So if the speed timer has reached, we go to here, and then we say, all right, load sprite direction, x. What direction does this sprite have now? And up. So sprite direction and up. Up was this bit. So we're loading this byte and compare and say we're saying and with this bit. Then we say branch if not equal. That means that branch if equal, that's if the result is 0. Branch if not equal, of course, that means that it's not 0. So by ANDing 2 bits together, 1, 1. So if there's a 1 at the bit position for both of these, so for my this bit, if there's a 1 here in this byte right now, so 1 at this position here, when we're ANDing them together, this will not be 0. So branch if not equal, move up. So then we go here. What does this move up thing do? Well, it decreases whatever's in my table sprite Y position. So we're decreasing that table, and now we know that the actual updating of the sprite actual memory positions, that happens in my raster interrupt. So hopefully that makes sense, but that's the up direction. So we have the same for the down direction, and then we get to a little check here. The first check we had was vertical speed timer. I have one here for horizontal speed timer. So I can have different speeds horizontally or vertically. I can have a sprite that goes super fast left and right, but it moves a little slow up and down, for example. Now, again, there are so many things we could have done. We could have given him some sort of acceleration that just starts moving slowly and then faster and faster and faster. The jumps, if we're going to make jumps in our game, we can have a smooth jumping arc that looks really nice. Now, I'm trying to reduce complexity because I'm sure you're seeing it already, that now we get to a stage where things get kind of complicated and you have to be really comfortable with assembly language to understand what's going on here. So I'm not going to do acceleration or smooth jumps like that. So those things are things you need to learn after the course. Now I'm trying to sort of get the basics in place. So I just wanted to mention that. So we're not going to have a smooth jump or acceleration movement or anything like that. Alright. So anyway, here's my sprite horizontal speed timer. Alright, check that. If we reach the same thing like before, if we reach that, then we go down here and we reset the horizontal speed timer. And we do the same thing that we did before. Check the different directions. So here, for example, check left direction. If sprite direction is left, then we decrease this table, sprite X position, for whatever sprite is loaded into X. So done move, then we get down here. And since this whole thing is in a loop, and we started by sprite 0 now, then we get down here and we say next sprite to handle, increment X. And we're comparing it to 8 here as well. 8 is the max number of sprites. Have we reached 8? Branch if equal. Well, if we have reached 8, then go down here to done handler. If you haven't reached 8, okay, continue. Then we get down here, jump handler loop, which is up here. Now you might be wondering why I did it this way. Usually we write branch if not equal, to some label. But here's the thing with branching. You can only branch 127 bytes, which means, let's just say it this way. Branching is limited. So if I have branch if equal, branch if not equal, and I'm going to try to branch to somewhere 1,000 lines further down, that's not going to work, because the branching is limited to 127 bytes in any direction. So we don't have to go into detail what that actually means, but branching is limited. So you could get some error message from your assembler saying branch out of range, for example. So that's why I do it this way. Branch, we are increasing X, comparing X to 8. Branch if equal. Well, if you have reached 8, then go here. That's no problem. That's just down there, right? But since I can't branch all the way up here, I do it this way. I just reverse the logic a little bit. Say, well, if it is equal, then we go down here. So if it's not equal, we go down here, which just happens to be a jump. Right. So a jump up here instead, because there's no limitation for jumping. You can jump anywhere you want in your code. No limitation. But branching has limitations like that. Okay, well, this was quite a lot. This was quite a lot. And at this point, like I said, hopefully you're starting to get comfortable with assembly language itself, because when you get to code that's as complex as this is, then I can't give a simple explanation for every single thing. So hopefully you got what I was trying to say, that we have two more libraries in our game. We have our input library and we have our sprite library, and we need to make those two work together. And also we need to remember to update our actual sprite positions in the raster interrupt. So it's starting to get a little complex now, but the result is that we have something that's kind of cool now. We have our background graphics, and now we can control a little sprite on the screen. So it's almost starting to look like a game now. So there's a reward for that, for the complexity. So yeah, I think we'll just leave it at that. But I'm gonna give you this code so you can study it on your own, and I'll see you next time. Bye bye.